Welcome back to section 11.3, Finding Complex Solutions of Quadratic Equations, Part 2. In this lesson, we're going to be looking at word problems. Let's look at the first one. A ball is thrown in the air with an initial vertical velocity of 14 meters per second from an initial height of 2 meters. The ball's height h in meters at time t in seconds can be modeled by the quadratic function h of t equals negative 4.9 t squared plus 14t plus 2. Does the ball reach a height of 12 meters? Let's go ahead and find out. So we want to figure out if the ball reaches a height of 12 meters, which means that h is 12. Let's take the 12 and plug it in. 12 equals negative 4.9 t squared plus 14t plus 2. We're using the quadratic formula to solve this, so let's go ahead and set our equation equal to 0 by subtracting 12 to both sides. Now we have 0 is equal to negative 4.9 t squared plus 14t, and 2 minus 12 is negative 10. Now let's identify a, b, and c. A is negative 4.9, b is 14, and c is negative 10. Let's use the quadratic formula. T equals negative b plus or minus the square root of b squared minus 4 ac all over 2a. Let's plug the numbers in, class. T equals negative 14 plus or minus the square root of 14 squared minus 4. A is negative 4.9 and c is negative 10. All over 2 times negative 4.9. Let's continue. T equals negative 14 plus or minus the square root of 14 squared, which is 196, and negative 4 times negative 4.9 times negative 10 is negative 196, all over 2 times negative 4.9, that's negative 9.8. So T equals negative 14 plus or minus the square root of 196 minus 196 is 0, all over negative 9.8. So we have T equals negative 14 plus or minus the square root of 0 is 0 over negative 9.8. Class, that's T, which is equal to negative 14. Negative 14 plus 0 is just negative 14, and negative 14 minus 0 is still negative 14. So I'm not going to split that up. Divided by negative 9.8, and when you type this into your calculator, negative 14 divided by negative 9.8, that's 1.42. So now let's make sense of the problem. Does the ball reach a height of 12 meters? And the answer is yes. The ball reaches a height of 12 meters at 1.42 seconds. Let's look at another problem. A person wants to create a vegetable garden and keep the rabbits out by enclosing it with 100 feet of fencing. The area of the garden is given by the function a of w equals w times 50 minus w, where w is the width in feet of the garden. Can the garden have an area of 700 square feet? Let's find out. Let's take the 700 and plug it into a. 700 is equal to w times 50 minus w. Remember, w represents the width of the garden. In order to solve this, we need to distribute the w and then go from there. So we have 700 is equal to W times 50 is 50W, and W times negative W is negative W squared. Class, now we have a quadratic equation, and with quadratic equations, they need to equal 0. Subtract 700 to both sides, and we get 0 is equal to 50W minus W squared minus 700. This looks a little messy, so let's rewrite it in standard form. 0 is equal to negative W squared plus 50W minus 700. Now let's identify A, B, and C. If there's no number in front of W squared, remember to use 1. So A is negative 1, B is 50, and C is negative 700. Let's take these values and plug them into our quadratic formula. W equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So W is equal to negative B is 50, plus or minus the square root of 50 squared minus 4, A is negative 1, C is negative 700, all over 2 times negative 1. Keep going, class. W is equal to negative 50 plus or minus the square root of 50 squared, which is 2,500, and negative 4 times negative 1 times negative 700 is negative 2,800. All over 2 times negative 1 is negative 2. So W equals negative 50 plus or minus the square root of 2,500 minus 2,800 is negative 300 over negative 2. Before we go any further, look at the number under the radical. Notice how that number is negative. So this tells me that my solution is going to be an imaginary number. And because it's imaginary, it doesn't exist. So just keep that in mind. I'll go ahead and simplify this just so that we can review simplifying complex numbers. So note the square root of negative 300. I have the negative, which turns into I, and the factors of 300 are 30 and 10. The factors of 30 are 3 and 10. And you know what? I'll actually stop here because if you notice, the 10s form a pair. And when you're taking square roots, the whole point is to get pairs. Now let's put everything under the same radical. We have the negative 3 times 10 times 10. Once again, the negative turns into I, and 10 times 10 would be our pair. 10 times 10 is 100, the square root of 100 is 10. And what's left under the radical is that 3. So the square root of negative 300 is 10I radical 3. Let's go back to our problem. W equals negative 50 plus or minus 10I radical 3 over negative 2. Now class, let's look at our whole numbers. We have negative 50, 10, and negative 2. Notice how all the numbers are divisible by 2. Let's divide by 2. W equals negative 50 divided by 2 is negative 25, plus or minus 10 divided by 2, which is 5, I radical 3, and negative 2 divided by 2 is negative 1. And I'll go ahead and leave my answer like this, only because I'm dividing by negative 1. So now let's answer the question. Can the garden have an area of 700 square feet? And the answer is no. The garden cannot have an area of 700 square feet because the width is imaginary. We have that 5i, making our solution imaginary. This concludes part 2 of our lesson. If you liked it, go ahead and give it a thumbs up and don't forget to subscribe.